Hello and welcome back to my channel. Students, in this problem series, we have taken up a very important topic, general organic chemistry. And in this topic, we have already covered a few important topics like carbocations, carbanions, aromaticity, anti-aromaticity, resonating structures, acidity and basicity. So I hope you all must be understanding the way I am explaining. I am trying to explain it on very fundamental level so that you can get the feeling of the topics. So now let us try to understand what is there for us in question number 22. As you all can see on your screen, you have a compound in front of you, and in this particular compound you can see you have 4 nitrogens mentioned as A, B, C and D. Out of these 4 nitrogens, you have to make a hierarchy and order of decreasing basicity. Now I have already told you to judge about the basicity of nitrogen. As you know, the nitrogen will have a lone pair. The lone pair can be given to a proton H plus, and therefore this nitrogen can behave as a Lewis base. Now, the order of basicity, the tendency of being a base, depends on what is the availability of electrons with which the nitrogen can give electrons to a proton. Higher the availability, more will be the basicity of that nitrogen. Now that is a point which is very important in most of the questions we come across. As we can see, there are 4 nitrogens. We will judge one by one the availability of electrons. If electrons are more available and they are not involved in any conjugation, or less conjugation is there, so that their deployment, their engagement in the conjugation, in the resonance is less, then the availability will be higher and the basicity will be higher. So that is a point to be noticed. So I will take up one by one and will judge about the availability of electrons. So I will start with the nitrogen number A. Student, as you see the nitrogen number A, you can feel that a lone pair is there, and a H plus can come to this nitrogen and can seek for the electrons. This nitrogen, if it can give electrons with eagerness, with availability, its basicity will be higher. However, if there is a presence of conjugation because of which lone pair can get delocalized, the lone pair will be less available in that situation, and H plus has to then wait for the electrons. I mean, H plus won't be getting electrons with that availability, so the basicity of nitrogen will be said as lower. Okay, so on that ground you should check the conjugation if at all it is present. Then you see this lone pair is in conjugation. How? Lone pair, single, double. And as you feel that a conjugation is there, there will be an obvious delocalization of electrons, and you have to move the lone pair one position ahead to make a new pi bond, as you can see. And as the electrons are going away from nitrogen, a plus charge will come on the nitrogen. Simultaneously, these pi electrons will shift on this carbon, bringing a negative charge and a lone pair, as you can see in your picture. So I mean, the H plus is looking at all these circumstances, the situation, and feels that I have come for electrons, and since electrons are engaged in some conjugation, therefore the availability is decreased. So if you are going to ask that hydrogen, did you get electrons from this nitrogen, so it will say the electrons were there, but those were not that much available because of the delocalization. And I have told you, higher the delocalization, more number of resonating structures you can draw, more you can spread the same lone pair on different atoms, lower will be the availability of lone pair on nitrogen, and the basicity will be decreased. However, in this particular case, you have seen that the lone pair got delocalized among two atoms, this nitrogen and this carbon. So two atoms are there who are going to share the lone pair, and in that sense the lone pair availability will be distributed, will be divided, and H plus is assessing all these things. Now H plus is going to see what is the situation with the nitrogen number B. If it goes to nitrogen number B, it asks for the electron, then we have to see whether the electrons are available for this proton or less available for this proton. So now we will see the situation number B. Students, in the nitrogen number B, again you have to keep your thought process the same way. Once you see this lone pair, then first of all you have to check the availability. For that you have to check if any conjugation is present with which this lone pair is in conjugation. Then on looking at this perspective, you find that the lone pair is in conjugation with 3 double bonds. How? Lone pair, single, double. So one conjugation you found. Next, lone pair, single, double. Other conjugation also found. Then lone pair, single, double. So simultaneously this lone pair is in conjugation with 3 multiple bonds. So you should understand, because of the presence of these conjugation sections, it will get delocalized, and for that we can draw 3 more resonating structures showing the delocalization with each pi system. So keeping that in our mind, we are now drawing the resonating structures. So once this lone pair goes in conjugation, let first of all take this pi bond into consideration. So these pi electron going to shift on this carbon, and from here you are going to get this structure. So you have seen that lone pair gone away from the nitrogen, a plus charge came, a new pi bond created, and the older pi bond is sitting on this carbon as a lone pair and a minus formal charge. Now you have to see the other conjugations as well in a similar manner. If you take this particular conjugation, then lone pair will shift in this manner and the pi bond will shift to this carbon, and from there you will get this structure. As you can see, again the nitrogen will be devoided of the electrons, getting the plus formal charge, making a new pi bond, and this carbon getting the lone pair, the minus charge. And similarly, these electrons could have gone to this situation, and these pi electrons would have shifted to this nitrogen. So from there you will get this type of a structure. And as you have seen, the lone pair on the nitrogen number B was quite engaged. Once I say it's quite engaged, the picture is in front of you. You can see that the lone pair is in simultaneous conjugation with 3 pi system, and if you count overall number of atoms where the same lone pair has got distributed, you will find that 4 number of atoms. How many? 4 number of atoms. It was here also, it was here, here as well as here. So altogether 4 number of atoms are sharing the same lone pair. So the availability of the same lone pair on the single nitrogen number B is going to be decreased substantially. It hampers, it decreases its basicity to a good extent. So that should remain your thought process. Now coming on to the nitrogen number C, and let us try again to see the availability of the lone pair. We find that again this lone pair, if we start trying to see if there is any possibility of conjugation, lone pair single single, lone pair single single, this is not the condition of conjugation. There is now no resonance found in the case of lone pair of C. So you remain assured that there is no delocalization of these electrons, and once H plus comes asking for electrons, it finds the electron on the nitrogen number C quite available, is always available, because there is no delocalization in the absence of conjugation. So you can say that this is the one nitrogen you have found till now, which will give you, which can assure you the availability of lone pairs, and therefore it will be the most basic amongst all we have seen till this point. Now coming on to the nitrogen number D. Students, as you see the nitrogen number D on your screen, you find that again there is a lone pair, and again you have to see the availability of electrons. You see that this lone pair is not in conjugation. How? Lone pair double single, lone pair double single. Now this is not the condition of conjugation of this lone pair going somewhere else. So you should understand that this is not going to do the delocalization of these lone pair, and the lone pair is going to remain localized at this nitrogen, and is a good news for the proton, which is now looking for the electrons. This is one aspect. The more important aspect is yet to come, and I have shown it in this resonating structure. Now student, you can see I have made one resonating structure. How? You can see how I have made this resonating structure from this diagram. You understand there is a lone pair on nitrogen number B, which is in conjugation with this double bond, as you can see. So once you delocalize these lone pair like this, these pi electrons are going to sit on nitrogen, and what magic it does, it creates now two lone pair. This is for the first time that you have seen a single nitrogen is bearing not just one but two lone pairs, and that has happened because of the presence of the nitrogen number B in conjugation with the double bond associated with nitrogen number D. So because of that conjugation, you find that the nitrogen number D is the only nitrogen which is you found the most prosperous in terms of lone pair, because till now none nitrogen other than D had lone pair more than one. This is the only one which has two lone pairs. So H plus will be the happiest while seeking electrons from the nitrogen number D, because this is where it gets lots of electrons. Because of this, nitrogen number B coming into a very important role. So after looking over all these situations, you come to a conclusion which I have concluded in the final slide. As you can see, the nitrogen of A, the nitrogen number A, here the lone pair because of conjugation is spread over two atoms. If we talk about the nitrogen number B, here the lone pair spreads over four atoms. If we talk about the nitrogen number C, here the lone pair remains localized in the absence of conjugation. And once you talk about the D, in the last slide, the previous slide, I have spoken a lot about this condition, how one of the resonating structure, when the lone pair is given like this and the pi bond shifts to this nitrogen, this is the only nitrogen which is seen to be most prosperous in terms of the number of lone pairs it has, because there it had two lone pairs, if you remember. So this is the nitrogen which comes as the most wealthiest, most prosperous in terms of electrons. So H plus is most happiest in this case, because it gets lots of electron. Now after looking at all the accounts of these nitrogen in terms of electrons, you come to conclusion that D is going to be the most basic. Then will come the place where the lone pair was delocalizing least. It was remaining localized so that it can be available for the proton. So then comes the number C, and then comes the number A, 2 atoms it is delocalized, and finally the least basic is found to be the nitrogen number B, where it got spread most number of atoms. So that is how you have to think in a fundamental, and you have to think critically how the lone pair is getting involved in some resonance, how it is not involving in resonance, and resonance may help creating more than one lone pair, as you got in the case number D. So I hope you all must have understood all these basic fundamentals I try to convey, and if at all you get any doubt from any section, any slide, you can write in comment section. I will be happiest person to rectify all those doubts. Till then, take a good care of your health and happiness. Thank you very much.